All right. Well, good morning, Core One peeps. It is 9:26 on Sunday night right now as I record this. Um, I was making a video earlier for Core Two, and I had the sunshine coming in, and now I've got the glow of my iPad illuminating my face. So the lighting is changing, but tomorrow when you guys are working on this, hopefully you've got a nice sunshiny day. Um, Welcome to Phase Two. Phase Two, we're going to kind of have a little bit more of this face to face. It might show up in the likes of an office hours Zoom call where you can jump in whenever you want and you can ask me questions live. Or it might be a video like this. But at least once per week, you're going to see me um, in some capacity. And I'm not sure. Sorry, I'm using Zoom to do a screen recording, and I'm not sure if my face is showing up. I think it is. I think I'm good. Okay, so I wanted you guys to see me first. This is me, Sunday night. I was just, what was I doing today? I can't remember exactly oh yeah, it was a pretty lazy day. I woke up, had lunch, a little time in the morning. I didn't sleep in too late. And then I went to my house in Holland and was working on some stuff there. I bought a new house, but we're fixing up, not really fixing it up, but painting and all that stuff. So I'll move in there this July, but it's kind of fun to kind of be there, see the progress coming through. So anyway, that's what I did this Sunday. So I hope you guys all had a good weekend. I hope you were able to do something fun and relaxing and not work on homework, especially when we're just so glued to our computers during the week, because it is what it is. It's the time we're in. But anyways, I won't make this video any longer than it needs to be. So I'm going to take my screen away so that I'm not too self-conscious throughout this process. But anyways, I look forward to seeing you guys someday once I have a Zoom call with you all. But today's not that day, but soon enough. So I'm going away, but we're going to be going through just a couple of things on quadratics and how to solve quadratics. What does it even mean to solve a quadratic? So a couple of things that Mrs. Hernandez and I decided that were essential and really necessary for us to hit home today are: one, what does it mean to solve a quadratic? Two, how many solutions could I get when I solve a quadratic? Three, making sure that I know how to set up quadratic equal to 0. And then 4, using the quadratic formula. And I'm going to give an example or two for that problem. So all right, sorry, there was a big pause there. I had to find my example problems again. They disappeared on me. So I hope that there wasn't too big of a gap in that recording. This is all new to me with technology. But anyway, so for starters, we're going to look at what it means to solve a quadratic. So we have, let's just say I've got my quadratic that goes through there and through there. This is my quadratic, and now notice it crosses right? So I've got my horizontal axis, right? So my x-axis and my y-axis. When I'm trying to solve a quadratic, essentially what I'm trying to find is what values of x can I plug in to my quadratic where it will give me these points out. So it's going to be question mark, comma, 0. Because remember, when I'm on the x-axis, my x is going to be some number, but my y is always going to be 0. Because, right, my y is how high or how low I am, right? Am I in the positive or negative land? Well, when I'm actually on one of the axes, when I happen to be on the x-axis, my height is 0. I'm not at all in the air. But now, what value of x goes in place there? Well, in this case, if I look here, we've got 1, 2, 3, 4, 5, 6, 7, 8. So it looks like that should be an 8 going right there. That was a really bad 8. And let's go this way. 1, 2, 3, 4. Negative 4 in the negative direction. So negative 4 comma 0. And 8 comma 0. So negative 4 comma 0. That was a really bad 8. And 8 comma 0. So those are my x-intercepts. These are referred to as x-intercepts because they are intercepting my x-axis. And those are the solutions to a quadratic, right? So if I imagine we're back in room 249 in Dielman's room, and I tell you, I need you to solve this quadratic. Now, we're going to learn how to do it algebraically, but graphically speaking, your mind should jump to this point right there and this point right here, and you should figure out what is that point? Or in other words, what are the values of x that when I plug them back into my rule, into my function, they give me 0 for y. So to think about this in a different way, if I am given, let's say we've got our typical standard form, y equals ax squared plus bx plus c. Now, essentially, when I'm solving a quadratic, I am replacing 0 for y and saying, when is my quadratic equal to 0? Because remember, if I am able to make this, right, so if I plug something in for x, this will give me some number equals 0. I want the number to be equal to 0. So what can I plug in for x such that it makes this whole equation become 0? And that's what we're going to be doing today and really the rest of this week is solving. How do I solve a quadratic? Now, you guys have seen an example of something before. You've seen 0 equals 2x minus 4. And I say, let's say I say, solve for x. Right, so what is x? So x equals what? What value of x can I plug in here such that it satisfies this equation where when I plug it in, this is equal to this. It's equal to 0. So what do you logically do? Well, when it's a linear, you're going to add 4 to both sides. And you're left with 4 equals 2x. Now, we're going to divide both sides, right? Because I'm isolating the x. Divide both sides by 2, and we're left with x equals, well, what's 4 divided by 2? That is just 2. So if I were to plug this back in, 2 times 2 minus 4, that's equal to 4 minus 4, and that's equal to 0, and that's what we wanted to show. So essentially what we're doing is this same process, but for a quadratic, right? So something with its x squared. And obviously, once we make our equations more complicated, finding our solution is going to be a little bit more complicated too. But there is a really fancy way that we can always find an answer to a quadratic. We can always solve a quadratic, and that's using the quadratic formula. Now, there's a couple of skills that we need to know ahead of time before we get to the formula. So bear with me, please. So first, I want to remind you, there are 3 potential situations of solutions with a quadratic. As I just showed you, with a linear function, right? Let's say I've got my coordinates and that's my equation. Now it crosses the x-axis at exactly 1 point. So there is one x-intercept, or there is one solution in this case if we're trying to solve when this linear function equals 0. Now, if I were to translate this to a quadratic, it gets a little bit more interesting because we've got 3 different scenarios. The first is the most typical. What if I've got a quadratic? Oops, I want red. What if I have a quadratic, right? Upward facing or downward facing, doesn't really matter. And it crosses my x-axis at 2 points. So here I've got two solutions. What if I've got one that looks like this? Well, you'll see that it crosses at exactly 1 point here. This will be an example of only having one solution. Now, the last but not least, what if I had a quadratic that just looked like this? Almost like it's just floating above the x-axis. I'm going over here, I'm trying to find, right? Is that where it's crossing the x-axis? Is this where it's crossing? Is this where it's crossing? Is this where it's crossing? No, none of those points are my x-intercepts. None of those are my solutions, right? Because I want it to cross this x-axis, but it's not doing that at all. So here we've got 0 solutions. Now, it's possible when we solve these quadratics, it's possible to get 2, 1, or no solutions. It's entirely possible. With the quadratic formula, you will see something strange will happen in our calculations when we are using that formula, which will reveal whether we have 2, 1, or none. But anyways, let's move on. Last skill I need to remind you of before we start doing the quadratic formula, and that is setting equal to 0. So setting equal to 0. Now, I hope you're taking notes right now. I put it in the instructions for this assignment to take your notes, take notes yourself so that you can look at these later rather than having to pull open my video and watch it all over, although that is easily a good option as well. Not a bad idea. But anyways, setting equal to 0. Let's say I've got the quadratic 4x squared minus 7x plus 10 equals 3x. Now, if I want to set this entire thing equal to 0, essentially, I've got two pieces here, and it's separated by my equal sign. I've got the left side and the right side. Which side has more pieces to it? Which one is more complete, would you say? If you're saying the left side, you're exactly right. So essentially, I want to move 3x squared to the right side, or sorry, to the left side from the right side. Oops. So how do I move 3x to the left side? Subtract. Yep, exactly. If you've got 3x, a positive 3x here, if I want to eliminate that from the right side, I should do a negative 3x from this side. In this case, since this is just an x, it's going to combine with the other just x variable there. And we're going to be left with 4x squared. Well, what's negative 7x minus 3x? That's going to be negative 10x. And then we still have plus 10, but it equals 0. And that is what we wanted. Bingo, we're good. So that's just a reminder of setting it equal to 0. And you have to do that before you solve a quadratic. That is essential. And all the problems that you see on your practice for delta are going to more than likely require you to set it equal to 0 before you solve the quadratic. So let's go ahead and do 2 examples. But you might be wondering, wait, Dielman, you haven't introduced the quadratic formula yet. And you are exactly right. I should probably do that. So the quadratic formula. The nice thing about a formula is that it will always work. So the quadratic formula is the following. When solving a quadratic, your solution will be, right? Now we're always solving for x, right? We always want to get x equals. So x equals, here is the formula. Some of you have seen this before, some of you haven't. If you've seen it before, great. If you haven't, this is something that you are going to need to memorize. You will need this in Core 2. You will need this in Core 3. If you move on to Pre-Calc or AP Calc, or you're going to need to know it. So the quadratic formula is the opposite of b divided by 2a plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Now you might be wondering, where are you getting a, b, and c from? Well, don't forget the standard form of a quadratic is ax squared plus bx plus c. So it's essential that we are able to identify what's my a, what's my b, and what's my c, and then plugging them in appropriately into our formula. So let's do a couple of examples with this formula. So example number 1, let me pull that up. Example number 1, and I'm going to write the quadratic formula in the corner. Did I say plus or minus? I did. Okay. So x equals opposite of b divided by 2a plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay. So my example is the following. X squared plus 4x plus 9 equals negative 2x. So step number 1, I need to set it equal to 0. So I need to move the 2x, the negative 2x to the left side. So the way I do that is I always do the opposite operation. So if I have a negative 2x, I should be adding 2x. That cancels here, plus 2x. And I'm going to get x squared plus 6x plus 9 equals 0. So this is my rule or my equation. Now what you always should do is identify what's A, what's B, and what's C. So A, B, and C. Well, A is always what the coefficient is that goes with x squared. In this case, it's invisible, which always just means by default, it's going to be 1. B is this guy, and that's 6. And C is our constant at the end, and that is 9. So let's plug in our solution. Or let's plug it in and solve for x. So x, I'm going to kind of divide the screen a little bit. So x equals, what's my b? B is 6, and I need to plug an opposite of that. So negative 6 divided by 2 times a. A is 1. So 2 times 1. Plus or minus. You might wonder, why do I get the plus or minus? Well, the plus and minus are what give you your two solutions. Quadratics often cross our x-axis in 2 places. So this plus or minus is where your x-intercepts are kind of coming into play. You're going to get one that's to the right and one that's to the left. The plus gives you the one to the right. The minus gives you the one to the left. So it's going to be plus or minus the square root of b squared. Well, b is 6, so it's 6 squared minus 4 times a, which is 1, and then times c, which is 9. And then all divided by 2a. So 2 times 1. All right, so there we go. That's step number 1. Step 2, x equals. Now, since we've plugged it in, let's start evaluating it. Let's start doing some of the algebra, some of the math here. So what's negative 6 divided by 2 times 1? Well, 2 times 1 is just going to be 2. So negative 6 divided by 2, plus or minus the square root. Well, what is 6 squared? That is 36. What is 4 times 1 times 9? Well, 4 times 1 is 4, and 4 times 9 is 36. Now remember, we're subtracting that number. So it's going to be 36 minus 36. And then that's all divided by 2 times 1, which is just 2. All right, step 3. Let's keep going. So x equals negative 6 over 2 plus or minus. What's the square root? It's going to be square root of 36 minus 36, so that's 0, all divided by 2. Well, some of you might know the square root of 0 is just 0. So we've got x equals negative 6 over 2 plus or minus 0 over 2. Essentially, this is negative 6 over 2 plus or minus 0. Well, if I do negative 6 over 2, well, that is, at this point, I know that I don't need to add or subtract any fractions, so I can make this become, I can simplify this. So this is going to be x equals negative 6 divided by 2 is negative 3 plus or minus 0. What's negative 3 plus 0? Negative 3. What's negative 3 minus 0? Just going to be negative 3. So my solution is x equals negative 3. It's only going to have one solution in this case, and that is exactly at the point x equals negative 3. Now I want to draw you a graph that kind of represents what this solution was, so you can see the visual of it. So if you need to pause and go back, rewind, please do that. I do not want you guys to get confused at any point. Feel free to ask questions as well on the previous problem, or sorry, on the Google Doc for the office hours. So this was x squared plus 6x plus 9. So it's crossing at, let's say we're going up by 2's. So 2, 4, 6, 8. So it's crossing at about here. That's our, this is our y-intercept, and we're exactly crossing at negative 3. So 2, 4, so right here at exactly 1 point. So my graph is going to do something like, only it's going to be touching it there. So my solution is exactly right here at the single point of negative 3. That was a very bad 3, comma 0. So that's my solution, negative 3, comma 0. So if I were to make the connection of, okay, so I've got my solution algebraically, I solved it and I got x equals negative 3. What does that mean? Well, at x equals negative 3, my graph is crossing the x-axis. Now, since I only had one solution for that problem, it's only touching it at that exact, only at that one single point. So if we go back to our possible solutions, that's an example of this one in the middle. So there is our graphical representation. Let's do one more. Let's do one more problem, and let's get a white blank piece. All right, example number 2 coming your way. So we've got, in this case, we've got 2x squared minus 6x minus 3 equals negative x. All right, we've got to set it equal to 0 first before we do anything else. So how do I get this equal to 0? Well, I need to get this guy over to the left side. So if I've got a negative x, I should do plus x to both sides. And that cancels out here, and we're left with 2x squared. Just realized I did another x. So that if I'm adding an x there, it goes from negative 6x to a negative 5x, and then minus 3 equals 0. All right, we are going to plug this into our quadratic formula, but let's first figure out what our coefficients are. So A, B, and C. Well, A, we've got a 2, so A is 2. B is going to be negative 5. That'll be interesting. And C is negative 3. All right, so step 1, let's plug it in. So X equals opposite of B. I have this by memory. You might want to have this pulled up, looking and referring back to what the actual quadratic formula is, but I've got this down by memory. So X equals opposite of B. Well, B is negative 5. The opposite of that is going to be positive 5. So 5 divided by 2 times A. 2 times A will be 2 times 2 because A is 2. So 2 times 2 plus or minus the square root of B squared, which is going to be negative 5 squared, minus 4 times A, which we said is 2, and C is negative 3. This is where it gets really dicey, and you need to make sure you keep the positive and the negative straight, right? Because when we get to this next one, negative 5 squared is not going to be negative 25. It's actually positive 25 because a negative times a negative equals a positive. So next step, X equals 5 divided by, well, what's 5 over 2 times 2? That's 4, 5 over 4, plus or minus the square root. Well, like I said, negative 5 squared, if you plug this in on your calculator and you don't put parentheses around the negative 5, you are going to get negative 25 as your answer. But really, a negative times a negative equals a positive. So it's going to be a positive 25 minus 4 times 2 times negative 3. Well, 4 times negative 4 times 2 is negative 8. Negative 8 times a negative 3 is a positive 24. So I'm actually going to be adding 24. Now this is all going to be divided by, oh, I missed a step up here. This is supposed to be divided by 2 times 2, right? 2a. So 2 times 2 is 4. So if you were confused about what I just did up there, some of you might have noticed I forgot to divide it by 2a on the right side of my plus or minus. So over here, it's opposite of b over 2a plus or minus the square root of b squared minus 4ac divided by 2a. And so I forgot to write that in. My bad, my apologies. All right, moving on. So x equals 5 over 4 plus or minus the square root of 25 plus 24 divided by 4. Keep moving on. So x equals 5 divided by 4. I'm going to keep this in fraction form because I might need to add and subtract fractions, and it's going to be a lot easier to convert. Just keep it in fractions rather than to try to convert a decimal back to a fraction. So 5 over 4 plus or minus the square root. What's 25 plus 24? Well, 20 plus 20 is 40. 5 plus 4 is 9, so 49 divided by 4. Let's keep moving. X equals 5 divided by 4 plus or minus. Does anybody know off the top of their head what the square root of 49 is? Luckily, it's a perfect square number. Give you a second. Maybe you calculate it with your calculator. Well, in this case, in every case, it's going to be 7 divided by 4. Still divided by 4. Now, here's where I have my two solutions. I'm going to have x is going to be equal to 5 over 4 plus 7 over 4. but it's also going to be 5 over 4 minus 7 over 4. I'm going to have two solutions. So I'm going to have x equals 5 over 4 plus 7 over 4. Or I'm going to have x equals 5 over 4 minus 7 over 4. And we're going to find that in the end, if let's say I do 5 over 4 plus 7 over 4, it's got the same denominator, so I can just add the numerators. 5 plus 7 is 12, divided by 4, and we know that 12 over 4, I can simplify that to just be 3. So there's one solution, but then my other solution, if we look over here, is going to be x equals 5 over 4 minus 7 over 4. So now I'm going to do 5 minus 7. That gives me a negative 2 over 4. And you all know that that can be simplified to negative 1 half, or negative 0.5, as you often know. So those are our two solutions to this quadratic. And represented on a graph, it is going to look like the following. So we've got 2x squared minus 5x minus 3. So we are going to have an upward facing parabola because it's a positive a value, and we're going to have a negative 3 is our y-intercept, so it's going to cross there, and our solutions are at 4 and negative 1 half. So at 4 and negative 1 half. So it's going to be a very, let's see if I can draw this. That was a bad drawing. So it's crossing at negative half and at 4, right? Because my solutions are, oh, that was silly of me. So 3 and negative half. So I need to go. Let's erase this guy. At 3. I was so proud of myself for that drawing. There we go. Fixed. So my solution is 3 comma 0. That's one of my x-intercepts. And my other one is going to be negative 0.5 comma 0, right? Negative half. And those are my x-intercepts. Those are my solutions to the quadratic that I just found. Now, what you guys are going to do is going to be a pretty small delta, potentially. It's possible that I changed my mind after seeing how long this video is, where you're just going to do some brief review of combining like terms or setting it equal to 0. But then you're going to try a couple of problems where you are actually just solving it with rational solutions, meaning you're going to have fractions or just whole numbers as your solutions, like what we had in my problems. So let me know what questions you have on that office hours Google Doc. Pause, rewind, fast forward, whatever you got to do to get through the video in its entirety so that you know what you're doing for your assignment tomorrow. You guys are amazing. I'm very proud of all the work that you guys are doing, and I will talk to you soon.